And so, as we have considered previously, we know four main situations that can cause earthquake. Tectonic, as we talked previously, 95% of all earthquakes. Volcanic, it is those earthquakes are those earthquakes can lead to very long earthquakes. Duration of those earthquakes may be several weeks. Also, landslide earthquakes, and technogenic. Landslide earthquakes, as we discussed previously, are connected with rockfall, with a huge mass of rock which can which can fall from big height in mountain region, and those rock falls, landslide earthquakes can cause a local seismic effect on not significant territory. But when we're talking about significant territories, the main causes for those are tectonic, volcanic, and technogenic. Technogenic earthquakes are the earthquakes which connected with the activity of human being. Among them, various uh, blasts which are connected with atomic or other or nuclear weapon. Also, those earthquakes can be connected with the activity of human being, which trying to корыстникопаланы, sorry, I forgot the term. Human being trying to get sources, some sources. One moment, I'll check the translation. Uh, Mineral resources or sources. Okay, so let's continue. So that is why for us it is really important to analyze the causes of earthquakes, which takes first place, and further we will discuss only tectonic earthquakes. So, additional for those who not good in English, I will explain it a little bit in Ukrainian. So, there are є чотири основні причини землетрусів. Серед них тектонічні, вулканічні, овальні, техногенні. А найбільший вплив викликає тектонічні. Власне, тому ми будемо далі розглядати лише ці сейсмічні впливи. So, to continue the discussion of this situation, we have to remind the all whole amount of information which is connected with the structure of our planet. So, as you remember, our planet has a layered structure, and the external layer, which we know really good, is our continental crust. Also, we know oceanic crust. Oceanic crust is not that thick as the continental crust. Also, we know that under the crust there is top mantle, bottom mantle, outer core, and inner core. So, and between them, we know various contact zones. Like the most important for us, it's Makharovich surface. Why is it so important for us? Because all these contact zone leads to the whole amount problems which connected with tectonic earthquakes, because our crust moves the parts of our continental or oceanic crust moves moves by top mantle. So we will make one more additional step, and in this step we will see that our crust also have layered structure which connect of the soils of the sial, it's called silicium aluminium surface, and these also we know Conrad surface, which divides granite layer from basalt layer. And all the problems that we know, almost all the problems that we know takes place in this main layer called continental crust. And to analyze the situation of those interactions of tectonic plates, we will discuss this slide furthermore. Do you have any questions about previous material that we have discussed today? Maybe additional explanation in Ukrainian. Is there anything clear or additional explanation in Ukrainian needed? Okay, okay. Let's move further. So, what's your? Okay, okay. Thank you for your feedback. So, all the problems which are connected with earthquakes leads from this situation. Here we can see all uh, important or significant types of tectonic platforms interaction. So first, it is called shift, or it is also may be called like the transform fold. It is these actions. So it is from the vertical point of view when we are looking on the surface of our planet from airplane or satellite, we can see these type of interaction of parts of our continental or oceanic crust, and in those places we can find significant mountains, etc., and those transform faults leads to the earthquakes. Next type of interaction of tectonic plates interaction called spreading. It connected only with oceanic tectonic crust. It takes place only underwater, and in that case, we can see these type of tectonic plates movement. And in this case, when our tectonic plates moves one from apart from another, in this case our mantle moves up, and we can find underwater volcanic actions. And in this case you can find the uh, creation of new tectonic plates. Uh, yeah, the creation of additional square meters for the existing tectonic plates. At the same time, we when these part of plates move one from the other, this part of tectonic plates move towards to the other. And in this case, we can see that part of our tectonic plates move downwards into the mantle. And in this case, we can see the dissolution of the existing tectonic plates. So in this case, we can see this part of the tectonic plate, we can see the dissolution of this plate, and in this case we can see the creation of the new part of the existing tectonic plates. So the same process takes simultaneous. Those processes are going simultaneously. Here we can see the dissolution, and here we can see the creation of the additional square kilometers of the tectonic plates. So when we have considered this situation, we have to compare this type of tectonic plates interaction compare it with this type of tectonic plates interaction. As you can see, those arrows are the same, but what the difference between spreading and rifting? And the only difference between them, it is the same type of tectonic plates interaction, but in this case spreading is connected with only oceanic tectonic crust. When we talk about rifting, it's only on the dry land it takes its place. That here is the only difference between spreading and rifting. Why is that so? It is caused by the next cause, because spreading, it is connected with the spreading of the ocean. So that is why this situation called spreading. Because it is connected with ocean, with the spreading of the ocean. In this case, we calling it rifting. So this and this, it is the same process of moving tectonic plates one from the other in opposite directions. And when we talk about subduction zone, subduction, it is the place where one tectonic plate goes under the another, and they moving in direction to each other. And in this case, we can see this interaction. And as I told you previously, in this case, we can see the dissolution of these tectonic plates. So, and here we can also get the significant earthquake. So, significant earthquakes can be caused by two main types of interaction. So, first, shift, this type of interaction, and second, subduction zone, where we can see the movement of tectonic plates one to another. And in this case, we can find this type of interaction. Spreading and rifting only in some cases can lead to the earthquakes, but in most cases those movements are not those places of tectonic plates interactions are not connected with significant earthquakes. So in Ukrainian, if you need additional types of interaction of tectonic plates, so subduction, spreading, and transform fold. And to deeply and for the deeper analysis of this situation, we have to analyze the map of lithospheric maps, or the map of tectonic lithospheric plates. So, as you can see, the most dangerous locations that we know from history are located here, Japan. Here, it is here. Oh, the most significant United States earthquakes, or the Southern American earthquakes connected to these zones of interactions, and the most cases of Argentina earthquakes are connected with these connection of South American plate with Nazca plate. Also, here we can see a huge interaction. So it is really interesting that the most dangerous earthquakes takes place where we can see such little tectonic plates. because little tectonic plates are the place of interaction of huge big tectonic plates, which were destroyed by significant earthquakes on these little parts. And when we talk about Ukrainian situation, we have to analyze this European the deeper analysis of the European tectonic plate. One more time. There is. I have one question for you. Uh, this map of tectonic plates, yeah, you can see this. Yeah, here is the same situation that we analyzed previously, but it has some differences. And I want you to tell me, oh, how do you think, what country have prepared this map? What country has prepared this map? So, oh, no, not country. The scientists from what country have prepared this map? Do you have any idea? Scientists from what country have prepared this map? I think Japanese. Any ideas? So let's change slide, and I'll. Which country used this world map? World map. Have you seen such map? Yeah, absolutely. You're absolutely right. So first watch what they made. They switched it in about the horizontal x in vertical direction, and located themselves in the center. So here is the one important problem that we have to analyze, because all the maps of the world and also the maps of tectonic plates interaction significantly differs from the point of view of the scientists that have created that map. And when we return to this map, what do you think? Which country have prepared this map? Cuban. No, no. Great joke. But this map was created by American scientists. That is why the center of this map is the United States. United States, yeah, Cuba is the geometric center of this map. Okay. So let's make one additional step, and analyze the local European situation. When we looking at this map, we can see this huge Eurasian platform. But when we are trying to perform the deeper analysis of this situation, we can find that that huge platform is also divided or subdivided to additional platforms, and our Ukrainian earthquakes are connected with this line of interaction. So here we can see it. This is it. And this type of this zone of interaction of tectonic plates leads to all the problems that we are discussing during this course from the Ukrainian point of view. So it's like we are trying to make the globe of Ukraine. So here our Ukrainian shield is the part of European platform, but main zone of interaction. By the way, we have our local earthquakes also in the Ukrainian shield, but most significant earthquakes to the whole territory of Ukraine is connected with this interaction zone. And uh, before this time, we have discussed the global situation of tectonic plates interaction. As we remember, that the most that 95% of earthquakes are connected with tectonic action, and we know that all Ukrainian tectonic problems are located in this case. But we have to know why is that situation takes its place. Why do those tectonic platforms moves one from the other? Why are not stable? Why are they still they in constant moving? Why is that so? In some cases, tectonic plates moves with the speed of 7 till 21 centimeters per year. So each tectonic plates move with this speed. And what leads to those interaction? What leads to that action? And we have to know that the theory that I will tell you right now, it is only the theory, but that movement of tectonic plates is caused by two main two main problems, maybe not problems. So first, it is convection in the mantle. So we have overheated liquid elements right here, and because of that their liquid state, we have some additional impact on tectonic plates, which leads them to interaction. It's like when you are boiling macaronis or boiling borscht, you can see that the action of boiling water leads to movement of macaronis, or leads to the movement of potatoes, cabbages, etc., which you have added to your casserole to prepare the borscht. So the same case, the same situation we can find on our planet. The convection in upper mantle leads to the movement of the tectonic plates. Another cause of this movement can be explained by the movement of our Earth. As we know, our Earth have a layered structure, so that is why when we considering this movement of our planet, we know that the higher level of our planet is solid structure, and the lower level of our planet is liquid structure. So that leads to the situation where the rotational movement of our planet, so upper layer moves with one speed, and the inner layer, which is liquid, moves with the other speed. So that is why we have this situation when our liquid part of our Earth moves with one speed, and exterior layer moves with the other speed. So that leads to the situation where our tectonic plates moves like an ice on the river. You have seen this videos of situation where a huge river in spring starts to move, and the crust of ice moves and interacts with each other with a significant noise. So same situation we have with our tectonic plates. So But in this case, we have not moving of the river flow. We have the situation of the moving of the upper mantle fluid, liquid minerals with one speed, and the upper layer of our planets moves with the other speed. So that leads to the situation of their interaction. So these two main cases leads to the movement of tectonic plates. So it is the combo of convection in upper mantle and the situation of moving about around moving of our planet around its axis. Do you need additional explanation in Ukrainian, or this part of lecture is also clear? No need. Yeah. Oh, okay. If you need, I'll tell it one more time. У верхній манті в нас є теплова конвекція. Теплова конвекція, має таку саму природу, коли ви у кастрюлі намагаєтесь зварити борщ чи макарони. І коли в нас кипляча вода рухається у каструлі, в нас макарони або там капуста, картопля, що ми варимо в борщі, вони розсуваються в різні сторони. Та сама ситуація в нас є і у верхній мантії, коли там є теплова конвекція, обумовлена рухом розчавленого матерії верхньої мантії, вона вимагає від тектонічних плит рухатися відповідно до тих напрямків руху у верхній мантії. Тобто це є перша причина, що заставляє рухатись тектонічні плити і викликати землетрус. Наступна причина, вона обумовлена тим, що наша планета вона обертається вокруг своєї осі, і при цьому в нас є деяка неузгодженість між цими рухами, бо внутрішня частина нашої планети вона у рідкому стані, власне, тому вона обертається зі своєю швидкістю, а зовнішня тверда частина нашої планети вона рухається трішки з іншою швидкістю. Відповідно до цього у нас і виникає неузгодженість у руху тектонічних плит. Цей ефект легко порівняти з кригоходом на річках, коли по весні в нас починає рухатися крига по річках, і тоді в нас вода в річці рухається зі своєю швидкістю, а частки криги на поверхні вони рухаються декілька з іншою швидкістю, і її частини взаємодіють одна з іншою і викликають дуже такий жахливий шум взаємодії криги при русі по річці під час кригоходу. Криголому. Так зрозуміло? Next slide, which can help us to understand that situation is the other slide, but it shows us in a better way that convection movement of the material in our upper mantle, which lead to movement of the tectonic plates of our planet. So during this part of our lecture, we have considered main problems which are connected with the movement of tectonic plates, and most most earthquakes takes place on the at the locations where we have those tectonic plates interaction. But there are some really strange earthquakes which take place not in the zone of interaction, but in some cases in the middle of tectonic platforms. And those earthquakes are called interplate earthquakes. Interplate earthquakes. So those earthquakes takes place in the middle of the earthquake. So let me explain this situation better. So most earthquakes takes place on this part or on this part of interaction of tectonic plates. But in some cases, we have situation where this part of tectonic plates moves in this way and this part of tectonic plates, for example, moves in this way. And in this case, you can see the significant deformation of tectonic plates in the middle, in the center. And this is the problem that we are trying to discuss right now. This is the problem of interplate earthquakes, where we can find the uh, mm, by the pressure or transform interaction of tectonic plates on the edges of tectonic plates, which leads to the deformations and cracks and also earthquakes in the center of tectonic plates. So not on this place and not on this place, but in the central part we have deformation of tectonic plates. In some cases, such deformation or such interaction can lead to creation of two platforms instead of one, because that crack in the center can lead to creation of new tectonic platforms, as we saw previously, not big platforms on the zone of interaction of North and Southern America. Uh, is this clear, or you need also Ukrainian explanation of this part? Що Константин? Так, добре. Тоді рухаємося далі. І зараз ми з вами розпочнемо дуже велику і таку інтересну тему called earthquake mechanics. So previously we have considered like intro to our main topic of this module. We have started discussion of no discussion investigation of engineering seismology, and in the before this part we were using in most cases well known for you well known for you terms and definitions. Right now we are starting big topic which leads us to important terms that we will use during our calculations and during the second model, where we will discuss earthquake resistance or seismic resistance of structures and buildings. So when we will discuss this topic, earthquake mechanics, we will analyze the situation in zones of interaction of tectonic plates. We will define how to measure earthquakes and what devices are necessary to define the earthquake activity, the level of earthquake activity. So first part of our earthquake mechanics is connected with this slide. Uh, this slide gives us an ability to understand the type of interaction of tectonic plates. So in this situation, we are trying to analyze what situation take place in the zone of interaction of the tectonic plates. So, in some cases during the earthquake, we can find the fault of the surface fault. Uh, in some cases, they looks like canyons. In some cases, they looks like canyons filled with rivers, etc. But it is not necessary situation to find the fault of the surface after the earthquakes. In some cases, in some situation, those faults takes place. Those faults uh, take those place underground without rupture of the surface. And the connection between two or more tectonic platforms takes place on some contact zone. So there is one tectonic plate, there is other. They have their contact zone, and those contact zones can be caused by this interaction, like for one two knuckles with one knuckles. In some situation they can look like this situation where we can find big contact zone. So in this case the earthquake caused by this contact zone will not be really strong because low surface, low amount of energy can be produced in this zone. When we have big contact zone, we have the ability to absorb big amount of energy, which leads to significant earthquake. But the mechanism of this situation is the same. Nevertheless, we have one knuckle contact zone or four knuckle contact zone. The mechanism is the same, but the difference between this earthquake and this earthquake is in the next. In this situation, where we have contact of two or more tectonic plates, we have the situation where where we are. I forgot the term. One moment. Oh, where we accumulate the energy. So in this situation, we are in a situation where we accumulate the energy. And in some cases, after accumulation of the amount of energy which is necessary to destroy the material of tectonic plates, we have an earthquake. So the amount of accumulated energy depends on the zone of interaction. And in this case, we can find, at this slide, we can find the surface of the earthquake, the surface according to which we have a contact zone and according to which we will have a fault of that surface, and only after that we will get the earthquake. In some cases that fault surface is vertical, in some cases it can be inclined, but nevertheless these type of interaction of these type of surface fault, we have two important points which give us an ability to better understand the description of earthquake. So first of all, this you know this term really good. This called hypocenter, and this is the epicenter. So hypocenter is the center of that fault surface, and epicenter it's the projection of hypocenter on the surface of the Earth. The epicenter is located above the hypocenter. So, and here we will find first important definition, but I will give you later. But in this case, so as the longer the length of this fault, the greater magnitude of the earthquake. Magnitude is one of the measures of the earthquakes, but we will take about this later. So, in other terms, we have a definition of this hypocenter point. In some cases, it may be called also focus of the earthquake. And epicenter is the projection of hypocenter of the on the surface of our planet. Distance between epicenter and hypocenter called focal depth. Here it is, focal depth. And it is really interesting questions because, as we know, the thickness of the crust of our planet, the of our tectonic plates lies in the range from 5 till 70 kilometers. That is the thickness of our tectonic plates. But in some cases, we know that some focal depths are located on the on huge depth from the surface of our planet. It's in some cases it's up to 700 kilometers. And the question for you for the next lecture is to think and prepare. Why do we have such situation when with the thickness of our tectonic plate 70 kilometers, we have an earthquake source, the focus of the earthquake on the depth, in some cases 700 kilometers. So I want you to think, and we will discuss on the next lecture. Is it clear or you need additional explanation? Добре, добре. Дуже важлива частина нашого курсу це є механіка землетрусів, і вона характеризується наступними визначеннями. В нас є гіпоцентр, це точка, у якій стається розрив контактної зони тектонічних плит. В нас є епіцентр, це проєкція гіпоцентру на земну поверхню. Що таке гіпоцентр? Гіпоцентр це є абстрактна така точка, що характеризує центр поверхні розриву. Так, в нас виникає така от поверхня розриву, іноді вона виходить на земну поверхню і утворюються каньйони тощо. Іноді це стається десь під землею, і ми навіть не бачимо таких розривів на земній поверхні. Але усередині стається така поверхня розриву, яка характеризується гіпоцентром та її проекцією на земну поверхню епіцентром. Ця дистанція між гіпоцентром та епіцентром, вона зветься глибиною осередку землетрусу. І ось ця дистанція між гіпоцентром та епіцентром іноді доходить до 700 кілометрів. І виникає питання, як так стається, що товщина нашої земної кори від 5 до 70 кілометрів. І як при такій товщині нашої кори можуть виникати землетруси на глибині 700 кілометрів? Тобто це також додаткове питання. Подумайте, поміркуйте до наступної пари, і тоді ми з вами зустрінемось і будемо дискутувати на цю тему. Як так стається, що при товщині земної кори 70 кілометрів виникають іноді землетруси на глибині 700 та більше кілометрів. Зрозуміло? Так, звичайно. Якщо є якісь запитання, то питайте, я вам буду давати додаткові пояснення. Наступна частина нашої механіки землетрусу це є сейсмічні хвилі, seismic waves. And all the waves, all the earthquakes that we know can be divided into groups. Body waves and surface waves. So today we will start from the body waves, and next lecture we will start from the analysis of surface waves. So first of all, when we talk about the earthquake waves, we have to know very important part. When we feel the earthquakes, or our building feel the impact of earthquake, we can feel the impact only one or two waves simultaneously, not more than one or two waves. Why is that so? It is caused by the situation with the speed of those waves. All seismic waves have their own speeds, and some of them faster than the other. And here on this slide, you can see the movement of P wave, primary wave, and only after here you can see here's this is P wave, and later you can see the S wave. So two body waves, first P wave and S wave runs after it. To better understand this situation, we can analyze this slide. So hypocenter, epicenter, and we can find the movement of ground particle in P wave. Here is the direction. It's like a beam of the sun, which moves in this way, and in it uh, moves like this. And this wave is the faster wave. Next secondary wave, it's S wave. It moves in this wave, in this way. Here is the direction of the secondary wave. As I told you previously, seismic waves helps us to define the structure of our planet and how it works. Here we have earthquake, and this earthquake can be measured by special equipment all over the planet. And it's really interesting that this earthquake can be measured over here, and absolutely zero impact will be right here. Why is that so? It is caused with the surface of with the layers of our planet. Because of the difference in state of core and mantle, we have various ways of seismic wave interaction. And this so-called shadow zone gives us an ability to describe the earthquake, the impact of, through the impact of earthquake, the structure of our planet. So, якщо українською, то усі сейсмічні хвилі вони поділяються на дві групи. Об'ємні хвилі та поверхневі хвилі. І таким чином ми з вами перш за все аналізуємо об'ємні хвилі. Вони звуться P хвиля і S хвиля. P це пов'язано з тим, що є поверхневі хвилі, S це secondary, P primary, S secondary. Тобто primary, тому що вона найшвидша, secondary, це пов'язано з тим, що вона повільніша. І ось ці хвилі от таким чином розповсюджуються у тілі нашої планети. П-хвиля, ось таким чином вона рухається в частках ґрунта, і вона таким чином розповсюджується. С-хвиля, вона ось таким чином, це хвиля здвигу. І вона рухається ось таким чином. І як я вам казав раніше, такі сейсмічні хвилі вони допомагають нам визначитися з структурою нашої планети. Це пов'язано з тим, що один той самий землетрус реєструється по всій планеті, але реєструється він по-різному. У деяких місцях реєструються і П та С хвилі, а в деяких місцях реєструються не реєструється нічого, а потім з'являються зони, де реєструються тільки П хвилі. І саме ці тіньові зони або приховані зони, вони надають нам можливість визначити, що десь нас під землею розташовані така шарувата структура і різні суттєві перепади у жорсткості тих шарів, вона надає можливість одним хвилям проходити через ці шари, а іншим не проходити. З таким самим чином землетруси надають нам можливість визначити будову нашої планети. По цієї частині лекційного заняття чи є якісь запитання? So according to this part of our lecture, are there any questions? No question at all. So let's move further and analyze P wave. So P, as I told you previously, P wave is primary or compressional or longitudinal, поздовжні хвилі. It leads to compression and rarefaction of the materials through which they pass. And to understand the movement of particles in that wave, it is easy to analyze the behavior of particles in such prism. When you hit with the hammer such prism, through the prism you will find the movement of the wave, and the wave will be moving this wave. So first you will see the compression, and then you will see a little, not significant, rarefaction. When we analyze secondary wave, which are S wave, which are secondary because they have less speed than P wave. They also called shear waves or transverse waves. They cause shearing deformation and they travel through the material in this way. So in this, to analyze this wave, you have to hit the prism from the side, and you will see this movement of particles in that prism. And this wave is always perpendicular to the direction of the S wave. So these two slides gives us an ability to understand two body waves that we have discussed, that we have started discuss previously. So we know that all seismic waves divided in two groups: body waves and surface waves. And body waves, in their turn, are also divided on two waves: P wave, primary wave, and S wave, secondary wave. P is longitudinal wave of compression, and S wave is the secondary wave, is shear wave for the horizontal transverse direction of its movement in materials. So that's all for today. Do you have any question about the material that we have discussed today?